Hi guys, this is Engineer Jack. Today mag-solve tayo ng example problem about sa transverse shear stress. So yung problem, determine the maximum shear stress acting in the fiberglass beam at the section where the internal shear force is maximum. So in solving shear stress or the transverse shear stress of a beam, this is the formula: tau equals to BQ over IB, where V is the shear force, Q is the first moment of an area above or below the neutral axis, I is the moment of inertia of the entire cross-sectional area calculated from the neutral axis. B is the width of the member's cross-sectional area measured at the point where the shear stress is to be determined. Tapos, this is the cross-sectional area of the beam. So, meron tayong width of the flange, 4 inch, and thickness of the flange, which is 0.75 inch. Then, meron tayong overall height of 6 plus 0.75 plus 0.75 equals 7.5 inches. Then, meron din tayong thickness of the web, which is 0.5 inch. So first, solve muna natin yung reactions in the beam. Solve AV, DV. Obviously, yung DH natin equals to 0 kasi walang horizontal force acting on the beam. So, summation of moment at point A equals 0. Equate natin lahat ng clockwise moments sa counterclockwise moments. Yung mag-create ng clockwise moment is 150 and 200 pounds na varying load. 200 pounds per foot. Solve muna natin yung area ng triangle or yung load is times 1/2 this triangle times 6 feet. Then yung moment arm niya about point A is, or ginawa natin concentrated load, yung 200 pounds per foot na varying load. Nakalocate siya 1/3 from this base. So ang location niya is 2 feet from this base. So 2 feet plus 2 plus 6 equals to 10 feet plus 150 pounds per foot times 6 feet. Yung location ng concentrated load niya is nasa centroid ng area. So nakalocate 3 feet from the point A. So times 3 equals, yung mag-create ng counterclockwise is dB times this moment arm. So dB times 6 plus 6 plus 2, so 14 feet. So dB is now dB is 4,350 over 7 pounds. This is the value of dB. Then, solve natin yung AB. Summation of forces vertical equals to 0. Lahat ng pataas na force, equate natin sa lahat ng pababa. So, mag-create ng lahat ng pataas is AB and DV. AB plus DB, meron tayong value ng DV is 4,350 all over 7 pounds. Equals lahat ng pababa, equal yan sa 150 pounds per foot times 6 plus the area of the varying load para maging concentrated load. So 1/2 times 200 pounds per foot times 6 foot. So AB now is 150 times 6 plus 0.5 times 200 times 6 minus 4,350 all over 7. 6,150 all over 7 pounds. So, kung mabalikin natin guys yung shear stress, VQ over IB, kasi yung hinahanap sa problem is the maximum shear stress, tapos yung shear force daw natin dapat maximum. Pag sa beams guys, yung maximum shear force natin, nakalocate yan palagi sa support. Yung pinaka-maximum shear, ito na mismo na AB, na 6,150 over 7 pounds. Ang ngayon, i-solve naman natin yung first moment of an area or letter Q, equivalent yan sa summation of area times Y, or Y is the moment arm of the area. And Q is the first moment of an area above or below the neutral axis. So, since asymmetrical yung area, pwedeng gamitin natin yung area above the neutral axis. So, let's say this is the area na i-consider ko. Tapos, i-divide ko sa dalawang area. This area 1, this area. Tapos, itong area yung pangalawa. So, dalawang rectangle siya, no? So, Q now is, yung area 1 is 4 inch by 0.75. So, 4 inch by 0.75 inch. This is the area 1 times yung moment arm niya from the neutral axis is 3 plus 1/2 ng 0.75. So, 3.375 inches plus yung area 2 natin times yung moment arm niya. So, yung area niya is 0.5 by 3. 0.5 inch by 3 inches times yung moment arm niya is the centroid of this area to the neutral axis is equivalent to 1.5. So, yung Q natin natin now is 4 times 0.75 times 3.375 plus 0.5 times 3 times 1.5. So, 12.375 cubic inch. Ito na yung value ng Q. So, meron na tayong value ng Vmax and value ng Q. Solve na naman natin guys yung I, or this is the moment of inertia about the neutral axis, or INA. Equal yan sa IG plus AD squared. So, yung consider natin yung area for this problem, let's say, yung pinakabuong rectangle, tapos ito yung dalawang butas, i-minus ko na lang para wala tayong AD squared. Kasi yung D natin is the distance of the centroid to the neutral axis. Pwede natin sabihin na yung pinakamalaking rectangle, so 4, yung base niya is 4, times yung height niya is 6 plus 0.75 plus 0.75, 7.5 inch cube all over 12. Since na yung kinuha ko yung pinakabuo, tapos centroid niya nasa neutral axis mismo, so wala nang isang AD squared. Yung binuo ko minus yung dalawang butas dito, 4 inch minus 0.5, so this is 3.5 divide 2, so 3.5 over 2, this is the base, times yung height niya, h cube all over 12, so yung height niya is 6 inch all over 12, tapos may dalawang butas kaya times 2 ulit. So ngayon, yung value ng I natin is equivalent yan sa 4 times 7.5 cube divide 12 minus 3.5, cancel ko na guys yung 2 inch times 6 cube all over 12. So yung I natin is 77.625 inch raised to 4. So ito yung value ng I. Yung kulang na lang is value of the B. B is the width of the member's cross-sectional area measured at the point where the shear stress is to be determined. So since na maximum shear stress yung hinahanap, yung B natin nakalocate yan sa neutral axis. So kung ano yung width at the neutral axis of the area, yun na yung value ng B. Yung web natin is 0.5 inch, ito na yung value ng B. So pwede natin i-solve, kompleto na guys, VQ over IB. Solve na natin yung shear stress, VQ over IB. Maximum shear force natin is 6,150 all over 7 pounds. Times yung Q natin is 12.375 cubic inch all over. Yung I natin is 77.625 inch raised to 4. Times yung B natin is 0.5 inch. So yung value ng shear stress natin is 6,150 all over 7 times 12.375 divide 77.625 divide 0.5 ulit. So yung value ng shear stress is 280.12 pounds per square inch. So ito na yung value ng shear stress natin.